in the fixing that. All right. Thank you very much. So let's look at introduction to statistical method. So we're going to be looking at class of statistics. We're going to be looking at variables. We're going to be looking at class of measurement. We're going to look at statistical text and assumption, and we're going to look at tests of statistical significance. And let me mention, just like I've said, some of us that have been following this section, and this section might be like a rehearing or probably like a recap to what we've learned, what we knew in the past. Now, in terms of class of statistics, we have two types of statistics. We have the descriptive statistics and the inferential statistics. Now, when we talk about descriptive statistics helps us in organizing, summarizing, and describing our data set. And the difference between the descriptive statistic and inferential statistics is that we cannot make a generalization or inference about our data set, all right? So descriptive statistics helps us to be able to describe our sample population. Now, so population is a total numbers of people under consideration. That is our target population of study. Then when we have the sample, the sampling, that is the fraction or the proportion of the population that is being considered for a study. So we have what we call a complete enumeration when we are considering all of the total population under consideration in the study into our survey or into our study. But due to cost implications and what have you, so there's something we call the sampling survey. That is when we take a proportion or a fraction of the population about which inference can be made to be able to describe our data set. Then the other class of statistic we have is what we call the inferential statistics. Now, inferential statistics, with inferential statistics, we can generalize. So with inferential statistics, we can generalize and we can make an inference about our study population, which implies now in our study design, when we have research questions, so research question can be responded to using our descriptive statistics. But when we have formulated hypotheses that we need to test the level of significance, if the hypothesis is significant or not, or if the null hypothesis or the alternative hypothesis has to be rejected, then the inferential statistics is the way to go, all right? So the difference between the two, descriptive statistics helps us to describe our data set, to summarize our data set, and to organize our data set, while inferential statistics helps us to be able to make generalization about the study population and also help us to be able to test our hypothesis. Now, let me move on here by trying to explain to us that in a research question, there are three broad types. We have what we call the difference, we have what we call the associational, and we have what we call descriptive, which implies in any research study, as it were, or in any study, as it were, the interest of the researcher is broad of three broad types. We have the difference, we have the associational, and we have the descriptive. Now, when your interest lies in comparing between groups or within groups, which implies you want to check for difference between groups or among groups, it shows that the type of statistic of interest is going to be like the t-test, student t-test, independent t-test, one-way analysis of variance, MANOVA. One-way analysis of variance is the ANOVA. Then we have what we call the MANOVA, that is the multivariate analysis of variance. Now, if your interest lies in association or difference, that means that you are looking at something like the chi-square, you're looking at something like multiple regression, or you're looking at something like the correlation, as the case might be. Then lastly, if your interest lies in description only, that is, you want to give a summary to your data set, then you might need to use the descriptive statistics, like the measure of central tendency, you know, the mean, the percentage, the range, and then what have you. And let me also mention that in statistical techniques, we have two types of statistical techniques. We have what we call the parametric test statistics, and also have what we call the non-parametric statistics. Now, there are various assumptions of testing if your data violates a parametric test, or violate a parametric test. So there's something we call the normality test. All right. So when you subject your data set to a normality test, you can actually tell if your data set is normally distributed, which means when your data set follows a normal distribution, it implies that a parametric test has to be used. But when you conduct a normality test on your data set and the data set does not follow a normal distribution, it implies that the alternative equivalent of a parametric test, which is the non-parametric test, has to be used in this case. All right. So let me move on here very quickly. Like I said, this is something that we are all familiar with, but it's important that, you know, I lay emphasis on this because we are different levels when it comes to statistics and also in understanding. And like I mentioned to us, that we've actually gone through statistical method deeply, but of course, due to some of the folks that are just joining us newly, and that is why it is actually necessary for us to give like a recap to statistical method as much as possible. And if you felt that, you know, you need something more deep, then we can actually share some of the PowerPoint slide deck that we've used in the past. All right. So descriptive statistics, like I said, can be applied to any measure in terms of it could be quantitative and it could be qualitative. Now, qualitative can be questioning because when you conduct a focus group discussion or a key informant interview, so how do you now apply the measure? So you will remember that when you have a qualitative study, that is data coming from FGD, KIIs, IDIs. So you could actually develop codings for your qualitative data by using themes. All right, there's something we call thematic analysis when it comes to qualitative analysis. So when you code your themes from the data coming from your FGDs, KII, or IDI, you can actually apply that measure as well to descriptive statistics. And like I mentioned to us, descriptive statistics offer a summary, an overview, a description of a data set, but does not explain or interpret the data, right? It only gives a of descriptive statistics that we can apply. The non-frequency, we have percentage, and we have the standard deviation, we have graphs, and we also have the normal curve. So which implies that these are some of the examples of descriptive statistics that, you know, you can subject your data set into in order to describe, to give an overview, or to give a summary to your data set. All right. So I'm not going to go into detail, of course, but I'm just going to mention this. Now, when we talk about the means of central tendency, we have what we call the averages. Now, oftentimes, I have discovered that people often interuse averages and also mean, all right? Averages and mean, they are two different things. So we have the averages of three levels. We have the mode, the median, and the mean. So mean is the arithmetic average, all right? So, but when we talk about averages, averages consist of the mode, the median, and the mean, which is the arithmetic average. Of course, we know that the mode is the most frequently occurring value in a distribution, which implies that your data set has to be arranged in descending order or in ascending order of sorry, that is for the median. All right, so the median is the midpoint in the distribution below which fall of the cases that reside, all right? So we need to get the median of your data set. So your data set has to be arranged in descending or ascending order of magnitude in order for you to get the midpoint in the distribution. And of course, the mean is the arithmetic average, is the sum of all values in the distribution divided by the number of cases. So if you are going to find your mean can only be applied to an interval or a ratio scale. All right, we're going to go that into detail. So we have 4 levels of scale of measurement. We have the interval, we have the ordinal, we have the ratio, and we also have the nominal. All right. So median can be applied to so we have what we call the inferential statistics. So inferential statistics allow for comparison across variables. For example, is there any relationship between one occupation and their reason for using the public library? So this is like an hypothesis that has been formulated. So inferential statistics, of course, for example, this is looking at relationship. So depending on the scale of measurement, so we could actually use a chi-square statistics or a correlation statistic to be able to check if there's an association or relationship between one's occupation and the reason for using a public library. All right. So inferential statistics allows for comparison and also for hypothesis testing. I said that the other time that when we formulate a hypothesis from our research question, so when you design a study, so the first point of a study is when you have a statement of problem. That is a research problem. So that is the beginning of your study. So when you have your a statement of problem, then you develop your aim and objective. So based on this problem, what is your aim? What is your focus in the study? What are your objectives? What do you intend to achieve? And from each of these objectives, you are now need to develop a set of research questions that respond to your objective. All right. So your research question, like I said, can be responded to using your descriptive statistics. Now, with your research question, you can now formulate an hypothesis for each or all or few of the research question about which inference can be made, or you can now test your hypothesis from the formulated right. So level of significance, we're all familiar with this. So the level of significance is a predetermined level at which a null hypothesis is not supported. So the commonly used one is when we have the p-value of 0.05. Of course, we also have a p-value of 0.05. But like I said, that a commonly used level is when we have our p-value at 0.05. Now, there is what we call decision rule in hypothesis testing. So decision rules states that we reject H naught if the p-value is less or greater than 0.05, then we accept if otherwise. I take that again. In testing, in hypothesis testing, so there's what we call a decision rule. So the decision rule says that reject H naught, that is a non-hypothesis, if the p-value, so the p-value is greater, is less or equal to 0.05, accept if otherwise. All right. So the P there is a probability. Then we have the less than in terms of the mathematical sign. All right. So when you are testing for hypothesis, so one of the things you look out for is the value of your P. All right. Is a part with the value of your P. So you compare the value of your P, that is the probability, the chance of occurrence, of your formulated hypothesis. You compare it with your p-value. So if your p-value is less than 0.05, so 0.05 is the alpha level of significance, then we can actually come to a conclusion if our test or hypothesis is significant or not, as the case might be. Let me move on here very quickly. So we also have what we call the error type. All right, we have the type 1 error, and we also have the type 2 error. So again, I'm not going to dwell on that as such. So one thing also that is very important that we also need to look into and also understand is what we call variable. All right. Variable is something that we deal with when it comes to data set, when we're collecting data, either electronically, either by paper-based questionnaire. So we deal with variables. So it's very important that, we understand the kind of variables that we're using for our data set. Is a variable continuous? Is it a discrete variable? Is it dependent variable? Is it independent variable? So when we are developing questionnaires, when we are developing set of questions, depending on the kind of research that, we want to do or go into. So it's very important that, we are able to understand the kind of variables that goes into our questionnaire design, and also the kind of variables that goes into the study, because the kind of variable that goes into the study also explain the type of scale of measurement. And the type of scale of measurement, of course, is going to determine the type of statistical techniques that is adequate and sufficient in able to describe our data set, and also for us to be able to test our hypothesis. All right. So as a way of definition, a variable is a variation within a class of objects. All right. Is a variable is a variation within a class of object, i.e. eye color. Then a constant is a characteristic with no variation within the class of objects. So we'll still go into this in detail. So researchers choose certain variables to study since they are suspected to be related to a possible relationship to be discovered. All right. So that is why I said it's very important that we understand variable when we need to design a study, because like I said, bullet point number 3, researchers choose certain variables to study since they are suspected to be related to a possible relationship to be discovered. Now we have what we call the discrete and the continuous variable. All right. So the discrete variables have a relatively small set of possible set of values. For example, we have gender, we have marital status, we have religion affiliation. So what does it imply when we say a relatively small possible set of values? Now, when it comes to gender, gender has a small possible set of values. For gender, it is either an individual is male or female, nothing else. So it is a close, relatively small set of possible, underline the word value. For gender, it is either you are male or female. Now, for marital status, it is either you are single, you are married, you are divorced, or you are cohabiting, or what have you. So it has a possible values. Religion affiliation as well, it has a relatively small set of possible value. Your religion is Christianity, is either your religion is Islam, or your religion is traditional, or what have you. So it has a possible set of possible values, and that is why we call it a discrete variables. All right. So the next one we have there is what we call the continuous variable, which theoretically assume any value within the lowest, now underlying the word lowest, and the highest point on a scale. Now, an example is time, is distance, is weight. Because for every weight, there's a starting point. All right. It could be 1, that is the lowest, then to a highest point. Then for distance, there's a lowest point. Maybe you start at 10 kilometers. So there's a lowest point and there's a highest point. Then weight, there's also a lowest point and a highest point. Salary is also a continuous variable because there's a lowest point in a salary and there's also a highest point or a higher point, as the case may be, on that scale, right? So these are the different. This is the understanding around discrete and continuous variables. All right. Let me quickly also mention that we also have what we call the quantitative and categorical variables. So variables also can be classified as either quantitative or categorical, all right? So a quantitative variable is conceptualized and analyzed in distinct categories with no continuum implied. For example, e.g. height, because this can be subdivided into smaller units, all right? Then we have what we call the categorical variables. So this does not vary in degree, amount, or in quantity, but are quantitatively different. For example, a political party, all right, and female, they are quantitatively different, all right. Educational level, primary, secondary, and tertiary. This male and female level of education, primary, secondary, and tertiary, all right. So this is an example of categorical variable because they do not vary in degree, in amount, in quantity, but they are quantitatively different. Political party, for example, they are quantitatively different, all right. So this is just an example. So one thing again that's very important that we are going to come with that we need to understand is what we call the dependent, independent, and dependent variable. So this is very important. If you need to run your regression, you need to run your binary regression, your logistic regression, your maneuver, your ANOVA, and what have you. You need to understand which of your data set are independent or dependent variable. So dependent variable as a way of definition is what the researcher studies to see its effects or relationship, all right? It is also what we call the presumed or the possible cause. Why a dependent variable is what is being influenced or affected by the dependent variable, all right? So your dependent variable, for example, now is your salary. So salary, for example, is a dependent variable. Now the question is, what are the factors that is influencing or affecting my salary? Remember, like I said, that salary is a dependent variable that can be influenced. All right. So you will all agree with me that in an organization, excuse me, in an organization, there are different factors that influence, excuse me, there are different variables, there are different factors that influence or affect salary. So those variables are what we call the independent variable. So your salary could be affected by your age, you're affected by your gender, your salary could be affected by your level of education, your salary could be affected by your level of experience in terms of your number of experience. So all of these, for examples, are dependent variable: your age, your gender, your level of education, your experience level. All of these are dependent variables that could be influencing or affecting my dependent variable, say salary. Are we together? Is that clear? So that gives a very good description to independent and dependent variable. Just like I said, the relationship between independent and dependent variable, this is logically explained in this flow diagram. So dependent variables are the presumed or possible cause that affect the dependent variables. All right, I think that is super clear. So these are other type of variables that I'm not going to go into detail. So one thing again that is also very important is the class of measurement. Like I mentioned to us, we have 4 levels of class of measurement. We have the nominal, we have the ordinal, we have the scale, and we have the interval. No, sorry, we have the nominal, we have the interval, we have the ratio, and we have the. I think I'm mixing it up now. Let me just go to the next slide. All right. So let me start by saying that measurement in research method is the foundation of any statistical investigation. All right. So I say that again. So measurement is the foundation of any statistical investigation. Why? Because everything, as it were, begins with measurement of whatever we want to study. All right. So it's very important to understand you define your variables, and when you're defining your variables, you need to understand the class of measurement in terms of the scale. All right. So everything we do begins with the measurement of whatever it is that we actually want to study. So by way of definition, measurement is the assignment of numbers to objects, either nominal, either scales, or what have you. Let me move on here very quickly by introducing us to scale of measurement. So like I said, we have the nominal, we have the ordinal, which is numerical. We have the nominal again, and the ordinal, which is non-numerical under qualitative. Then we have the interval and ratio, that is numerical under quantitative. I'm sure we know that data set can be of two types. We have the qualitative and we have the qualitative. And that is why in research study, when we see that the study adopted a mixed research approach, it means that both the qualitative and the quantitative study was actually used in that study. All right. Measurement, it includes the nominal, the interval, the ordinal, and the ratio. So the scale determines the amount of information that is contained in the data. So the scale also indicates the data summarization and the statistical analysis that is most appropriate. So this point number 2 is very, very key, right? So scales, that is nominal, interval, ordinal, and ratio, it indicates the data summarization. Most importantly, this appropriate statistical analysis or method that is, to be used. So scale helps us to be able to tell the appropriate statistical method that can be used in analyzing our data set. Okay, so number 1 is nominal. So nominal, that describes it. I don't want to go into detail because of time. So an example of a nominal scale is education, is gender, is location also as well, just that I've explained that. So data are labels, are labels or name that are used to identify an attribute of the element. So another one we have there is ordinal. So ordinal are data property of nominal, so that are ordered. They are ordered or are in rank, right? So for example, okay, yeah. So the ordered, so it has an identity, it has a magnitude, all right? So when you have a magnitude that are ordered, is an ordinal, all right? So then we also have what we call the interval, all right? So interval data are always numeric. So note that. So interval, it has an identity and it has a magnitude. It also have a known distance between the values, all right? We also have the ratio, all right? Then variables such as distance, height, weight, and time are example of a ratio scale, all right? So it's important we also note that. And this gives the features or the characteristic of ratio as a scale of measurement. So this gives like the overview of the level of measurement. We can see we have the nominal, the ordinal, the interval, the ratio. Then we can see the examples, the properties, the mathematical operation, the type of data, and the type of comparison also that can be made. They also have statistical assumption, test and assumption. I'm not going to go into detail into this as well. So we have what we call remember I said to us that we have the non-parametric and parametric statistics, non-parametric and parametric statistics. So at any point that the assumption of the parametric statistic is violated, then the equivalent of non-parametric test is going to be used for data analysis. So it's important we also know that. And I said to us that we can use what we call the normality test. So we can use the graphical method or the statistical method in testing if our data set follows a normal distribution or not. So when our data set follows a normal distribution, then we use a parametric test. But when our data set does not follow a normal distribution, then we use the non-parametric test. So it's important we also know that. So we have the Pearson correlation, and these are some of the assumptions. Okay, we have two assumptions: assumption 1 and assumption 2. All right, like I said, like assumption 1 now, 2 of the variables should be measured at interval or ratio. Okay, i.e., there has to be continuous. And these are some of the examples of variables. All right, we also have what we call the chi-square. So 2 variables should be measured at ordinal or at nominal. Then the second assumption is that the two variable must consist of two or more categorical or independent group. We also have the regression, all right? The regression, you must have the dependent and the independent variable, all right? So for regression, you can have the simple linear regression when you have one dependent variable and one independent variable, but we can also have the multiple regression when we have one dependent variable and more than two independent variable. Then we can have our equation line. Then we also have the binary regression. In this case, your dependent variable has to be binary, all right? It's either 0 or 1, yes or no, all right? So if you have to use binary regression or what was called the logistic regression, the assumption 1 is that the dependent variable must be binary, all right? Then the assumption 2 is that there should be one or more independent variable that could either be continuous or categorical, as the case might be. We also have what we call the test statistics, that is the t-test. We have the independent t-test, the student t-test, and what have you. So these are some of the assumptions: assumption 1, assumption 2, assumption 3. Then we also have what we call the one-way analysis of variance, all right? One-way analysis of variance, and these are some of the assumptions for assumption 1, assumption 2. Like I said, I will not be going into detail with all of this. All right, this is what we call a post-comparison test. So when your F statistic is significant, then it's important that a post-comparison test is conducted on your variable. So we'll go into this in detail by the time we are looking closely into STATA. So this is the difference between two groups, all right? So we can see the parametric test and the equivalent non-parametric test. Now, when your interest lies in comparing mean value for some variables of interest, then you subject your data to t-tests for independent sample. However, if your data set does not follow a normal distribution, then you have to use other tests like Manit's and Man-Whitney U test or Solomon Groove two-sample test. This is the non-parametric equivalent of the t-test. Then differences between independent groups. So if your data follows a normal distribution, then use analysis of variance. It could be ANOVA or we could be MANOVA. MANOVA is a multivariate analysis of variance. But if your data set does not follow a normal distribution, then the equivalent non-parametric test is what we call this Kuska-Wallis analysis of rank, or what we call the median test. All right. So again, if we want to compare two variables that are measured in the same sample, so the parametric is a t-test for independent sample. The non-parametric of it that can be used is what we call the sign test, or what we call the Wisconsin matched pair test. All right. Then we can also use what we call the repeated measures ANOVA. So, but when your test fails that, you use what we call the Friedman two-way analysis of variance. That is a non-parametric equivalent of a repeated measures evaluation. All right, so this gives the summary table of statistical tests. Okay, so I think I've explained this test of statistic. If your statistic is higher, so there are two differences you need to understand. There's what we call the statistic. Okay, and there's what we call the statistic. So the statistic, the one without the S, is the method. All right. So if your statistic is higher than the critical value from the value, so there's something we call the critical region of acceptance or rejection in statistics. Again, I'm not going to go into that detail. So, but for this, your critical value, depending on when you're using the one t-test or two t-test. But however, if your statistics is higher than your critical value, it means your finding is significant. It means you reject the null hypothesis. That is, the probability is more that the difference or relationship happened by chance, and the p-value is less than the critical value. That is the alpha level, 0.05. All right. So when your p-value is less again, when your p-value is less or greater than, If your p-value is less or equal to 0.05, it means that your finding is significant and your null hypothesis will be rejected, all right? So when your p-value is less or greater than the 0.05, it means that the probability is more that a difference or relationship happen by chance. However, if your statistic is lower than a critical value from the table, it means your findings is not significant, and then what have you. So this takes us to introduction to STATA menu and dialog box. So at this point, before I jump to this, I'm going to pause to take questions. So I've looked at the chat box. There is no question as such, but I'm going to allow one or two individual who has any questions or clarifications to make. You can drop that in the box, then I'm going to respond to it appropriately. Questions, clarifications. If you are good, just tell me you are good, or tell me proceed, that you are fine. But if there's any clarification, just post it in the box, then I'm going to take it out. But if you are good, just reply in the chat box that please proceed. Hello. Okay, excellent. Are we all good? Can I proceed? All right, thank you. So I'm proceeding. So thank you very much. So what we've learned is just an introduction to statistical method, which is very key in whatever we need to do with STATA, and even in every other statistical method, STATA, SPSS, SACS, and then R, and then what have you. So we want to look at very quickly introduction to STATA menu and dialog boxes. All right. So let me say this to us, that STATA is like every other statistical package. All right. Like we have SPSS, R, SAS, and what have you. So they are all statistical packages, but of course, they have some merits. Some merits and dismerit in terms of their capability and flexibility, their output, and then what have you. Now, as an overview, we're going to look at about STATA, STATA user interface, interacting with STATA, and command for basic data reporting. All right, so this gives a quick overview about STATA, which of course I'm not going to go into that detail. Of course, it's a general purpose statistical software that was created in 1985 by STATA Corp. The capability include data management, statistical analysis, graphics, data stimulation, regression, and customized programming. And one important thing about STATA is that it uses a command, and also it's a menu-driven software, which means that you have a drop-down menu, and you can also use a command line for a statistical analysis. All right. So these are some of the advantages. I'm not going to go into that detail. And these are some of the disadvantages as well. And I'm not going to go into that detail. We can actually read that up. All right. So let me move on here very quickly by saying that in terms of the STATA interface, so after accessing STATA, now when you have installed STATA on your machine, and you can actually go through the start menu to get I click on the STATA icon. Or you can actually create a shortcut at the taskbar, and you can also have the icon also on your desktop. So depending on where you have it. So after accessing STATA, by clicking on the STATA icon, there are 5 main windows you will see, and we're going to review that into detail. So there are 5 main windows when it comes to STATA. We have what we call the history or the review window. We have what we call the result window. We have what we call the command window. We have what we call the variable window. And lastly, we have what we call the property windows, all right? So we're going to be looking at that in detail in the subsequent slides. So please note it, 5 main windows: the history or review, the result, the command, the variables, and lastly, the property windows. So except for the result window, each window has its name in the title bar, and we are going to see that shortly. All right. Then also, there are other more specialized windows such as reviewer, data editor, and variable managers, do file editor, and graph editor window. So more often, I call this window like the formatting tool. All right. So formatting tool. We're going to look at that into detail. Now, this is the interface. All right. When you open your the STATA environment, what you see at the left-hand side at this point, if you can see my cursor, this is where your past commands appear, all right? So when you put your commands here, so the commands are typed in here, all right? So past commands actually appears at this point, all right? You can see my cursor. Then this is the current window directory. It appears here, all right? The directory, so it appears here. So this is where the results are being displayed. All right, you can see my cursor, result are displayed here. So this is where you have the list of your variables. All right, the list of the variables appears here. Then this is where you have the properties for each of these variables. All right, you can see, for example, history. History is written here. All right, you can see my cursor. This is history. This is command. This is a command. So this is history window. All right, at this point, where you have your pass command, where it appear, we have the command window. This is this point where you can type in your codes or your command line. Then this point where you can see the result display, it is called the result windows. All right. Then we have what we call the variable windows. All right. At this point, you can see my cursor, and this is where the list of variables appear. Then lastly, we have what we call the data property windows. So this is a property windows where you have the properties for each of the variables at this point. All right. So this is command window. So command windows is where you can enter your commands directly. So you can enter commands directly into your command window at this point. Then this command will load a data set over this internet. So this is a command that says web use auto comma clear. So this command is going to load data from the internet directly. Then you can go ahead and enter the data. So when you put this, you just click and enter, then it runs the data set. All right. So this is the command window where you enter your commands directly. Next is what we call the variable windows, just like I've mentioned to us. So once you have loaded your data, variables in the data set will be listed with their labels in the order they appear on the data set. All right. So the variable windows, when your data is loaded, the variable in the data set will be listed with the labels in the order they appear. So clicking on a variable name will cause its description to appear in the property window. So let's say, for example, if you click on make, this is the variable name. If you click on make, then the properties for the variables make will appear in the property windows. And again, when you double click on the variable name, it will cause it to appear on the command window. What does that imply? So if you double click on the make, it appears on the command window. All right. This is a command window here, and this is a command window here. Next is what we call the property windows. So this variable section lists information about the selected variable. Remember I said, now make here is selected. You can see that in the variable window. So make here is selected. Now you can now see the properties in terms of the variables and the data for make. You can see that. So this is make, and the label, the type, the format, and the file, the label, and then what have you. So that explains the property windows. Now, the next one is what we call the review windows, and this is it here. All right, by the left-hand side. So the review windows list previous issued commands. Will appear in black that runs success again. So if I want to run this command again, if I double click it, it runs it again. All right, instead of having to write the command over and over again. So you can see reuse some of the command you've used in the past. So when you double click this command, then it reuses it. They will recall previous use command to pay to recall a previous command that has been used. So the next one we have here is directory. All right, then we can also see at this point. Then the last one is what we call, okay, that's that. So the next thing is what we call the stata menu. So this is the stata menu. So almost all stata users use this syntax rather than in stata. You don't want to go in, really go to, for example, graph. You click on graph in the menu bar, then you have a pull down menu to select from. When also go to statistics in the menu bar, they also have a pull down menu to choose from. So it's either you work with command or you use statistic, for example. You can easily go to statistic in the menu bar and using through the use of the dialog boxes. You can go to graphics in the menu bar and through the dialog boxes. And if you do not want to go through the route of menu system, you can actually go to the route of command window. All right, you can actually choose your command by tab, and what have you. Then I can also use what we call the do file editor. So we're going to go that into detail. So do file editor is where you have all your do files kept for future use. All right. So and the first one, the menu system, I've explained that. And there are two ways by which you can tell Stata what you would like to do. It's either by menus or by dialog item. So clicking the appropriate menu and dialog will help display your command in the command window. Then also, you can also use the command windows. So commands are submitted to Stata from the command window. So command windows support basic text editing, copy and pasting, a command history, function key mapping, and also variable name completion. Another way is by using the do file editor. So Stata comes with an integrated text editor that is called the do file editor. It can also be used to build up a series of commands that can be submitted to Stata all at once. All right, we're going to see the bits of this in time. Then do file editor also helps in minimizing writing commands over and over again. And in turn, it actually saves time. So the menu system is organized in a logical way to help you to find the tool you need. Like I said, you have that in the menu bar. So the dialog boxes also allows your selection options that are available for a task. So you can click on a question mark on the bottom of the dialog box, and it takes you to, so we're going to see all of that in detail by the time we start interacting with Stata directly. But this, of course, is just like an introductory for us to have a basic understanding around this. So command for basic data reporting. All right. So the number one thing we need to do is that you need to describe your data set. You need to check your code book. You summarize, browse, edit, you tabulate, you list, you count, and you inspect. All right. So these are the basic data reporting process. You describe, you check your code book, you summarize, you browse, you edit, you tabulate, you list, you count, and you inspect. Right. So this just gave ways by which this can be done. All right. This is describing your data set. So you can go through the menu bar to initialize describe. You click on menu, you go to the option, all right, and this can actually be done. Like I said, you all understand the beauty of this by the time we start working on STATA directly. Then, so when you describe, then this is the output. Of the menu option to describe data then, all right. So you want to summarize, you can go through the menu option. You click on statistics on the menu bar. You go to summarize. You click on table and test. Then click on summarize. Then you have that done. Then you have all of this. You can summarize all your data set. Then we click on OK. This is going to be the output. So we have the variables, the numbers of observation, the mean, the standard deviation, the minimum, and the maximum in terms of the variables that we have in there. Then the next thing is to browse, all right? Because to edit or to inspect your data set. So this also, we are going to look in detail when we start working directly with STATA. Then the other one is to tabulate, okay? So this is the menu option in tabulation from statistics. We click on OK, then we have this output. So this is what we call the frequency table. So we can see the frequency for each of these hospitals, then we can see the percentage and also the cumulative as well. Then the last one is that you can also, I think you can also list your data set. All right, this is the process you can go through. And then when you select your variables, or you can leave empty if all of the variables of interest, then you click on OK. Then click on OK. Then, okay. Then this list, then you can list your variables. This is listing 1 to 10. You could list 1 to 20, depending on what you really want to see. All right. Then I move on. Then you can also do counts, depending on what you want to see. You can count numbers of observation. All right. You can also go to that menu and data utility counts. Then it counts the numbers of observation that you have in there. And this and what we have here is the output, the numbers of counts. All right. You can also inspect your data. So for example, we want to inspect age as a variable. So you can go through the menu bar, click on data, from data to describe data, then to inspect data. Then select the variable you want to inspect. Then this gives the output. The listing, if you can also use the command line, inspect age. All right. So if you do not want to go through the menu bar, remember I said to us that there are 3 ways we can interact with STATA. Number 1 is by menus and dialog boxes. Number 2 is by command line. Then number 3 is by use of do files. So now what we have here, when you go through data to describe data, to inspect data, this is going through the menu and the dialog box. All right. So if you do not want to go through this menu and dialog boxes, if you type in inspect space age on your command line, then you are going to see what we have here on the result window. All right. So this is actually inspecting the age, numbers of observation, then total are negative, 0, positive, missing data, numbers that are integers, numbers that are not integers. So it's very important that before you start your data analysis, you need to carry on all of this process. All right. Before any data analysis, you need to describe it, check your code book, summarize, you browse the data to inspect it, you check, browse or edit, you tabulate it, you list it, you check the count, and you inspect the data. So when all of this is done, before you can actually start data analysis or what have you. So at this note, my work is done here. Thank you, and over. So I'm going to allow Dr. Benga to coordinate the next phase in terms of question asking, clarifications, and then what have you. So as from such, so we're going to be interacting directly with STATA. Everybody has STATA installed on their machine, as the case might be. So, Dr. Bay, can you answer questions or what have you? Thank you, everyone, and over.
Thank you.
Dr. Benga, please.
Yeah, thank you so much, sir. Thank you for that background, solid background that you have given us. I think it's actually a very responsible building from the next time.
Sorry,
So
your line is your line is breaking. Is it my network or your network?
It's my network. My network is very bad.
Okay, please proceed. Please go ahead, please.
Okay. So I said it's actually a very good background, and it's a way for. So we have some to do, but we have one major challenge. The last time we were in class, we found that the STATA 15 that we shared with people could not do so. We could not do refresh.
Sorry, we are losing you. I can hardly hear you, Dr. Benga.
Apologies.
Would you want to type in the box? Would you want to type in your comment in the box? And please, if we have questions as well, can we also drop it in the box? In the chat box, please. Or probably it implies that, I mean, we are clear and we are good with the presentation. Dr. Benga, can you please drop? Please, if you have questions, can we drop? Casey, question. Dr. Joshua, Dr. John, Ogolua. Please, let's drop our questions and then please, Dr. Benga, please still drop what you're trying to tell us. I can hear you, or we can hear you. Okay, if there are no questions, can we take feedbacks? Okay, yeah. So I'll share my version. Okay, please go ahead.
Okay, it's not a question. I think it was I really learned a lot from what you taught, and I really love it. I can't wait to start practicing.
Excellent. Thank you very much for feedback. So, Dr. Benga, I'm going to share the version of my STATA statistic. I mean, STATA. STATA. Take it on. Yeah. Thank you very much. Thank you. That's yeah. Thank you very much. John. I know that Adedeji was once with us again, so I'm sure that some of the things is just like refreshing his memory. Thank you again for joining us. Thank you very much. So at this note, it seems we are all good, that there's no questions, and we are